Hello, this is a note about connecting a live GPS to qtVlm. This is a qtVlm running in a Mac computer, and then I'm going to connect using the Wi-Fi output of qtVlm running in an iPhone. So I have this iPhone sitting here, and it's running the qtVlm app, and it will broadcast all of the GPS signals that it receives, plus all the sensors that are internal to the device. In particular here, the barometer, the heading, and the heel angle. And we did this, we showed before that there is this app called GPS to IP that will do it, that will transfer the position. And this is another way to do it. This is an app in the App Store. This one, it has a demo version, which is interesting to look at. It's a very powerful tool, this Apple or Android version, and you'll see it's essentially identical to running the PC or the Mac version in here. So we're going to use this one. So when I have to touch the phone here, I'm going to turn that on. And so there's the app running here, and then the controls are down here, and so I have to set this up to do this. So I hit this, okay, let's see, I have to point here. Okay, then I'm going to press here, that's the configuration, and then let's see, then I want configuration here. Oh, I punched it wrong. Okay, my fingers are... okay, so I'll try again, qtVlm, then configuration. Now we're back to want NEMA connections. That's here. So this is the same as looks just the same as on the PC or Mac version you're used to. So here's the NEMA automatically start. These are not related to what we're doing. We are using the internal GPS, so that's a check mark here. And we're going to send to the NEMA output. So that's there. We're going to everything that we read, we're going to put out, and we check both of those. And now the first thing we're looking at here is input to the app in the App Store. So these are all the input stuff. We don't care about that. We're going to use the internal sensor. Here's the output. And we'll just take this first one, UDP, and frankly, with this device, it works real well. You can put almost anything you want here for this IP address right here. I just put all zeros, and I put the port as a 10110. Doesn't matter. And then you turn that on, retransmit all signals, and then let's see if there's anything else impertinent down here. Current data, okay, from the time. All right, then you have to be sure, as always, to go down and hit OK. So, okay, got to click it on the phone, not on there. Okay, so there it is, and then I set up this app here to show the things it's going to transmit. Besides the cog and SOG and position, it's going to also transmit the heading. This has got a heading sensor in the phone. It's got a goniometer, a thing that'll measure heel and pitch. And I didn't show it, but I did shut off the pitch. Otherwise it sort of alternates pitch and heel. We don't really care about the pitch, but we care very much about the heel angle. That affects your true wind calculations and everything. And we care about the pressure. These phones have very good pressure sensors in them, so we want to use them if we can. So now that should all be working now, and it should be broadcasting this as a Wi-Fi signal. Like this is essentially a hotspot. It's a backup set of instruments. If all your instruments on your boat fail, you can pull out your phone and have GPS, heading, pressure, etc. Okay, now we got to go back to here, qtVlm preferences, then NEMA connections, and now it's not a local source like we did with the USB and Bluetooth and all that, but we switch over to network sources, and here's where I set it up. I just did a port 1. It's a UDP. That's what we had over here. And a 00 and that 110. So that should, in principle, if everything's right, that should work. So I say OK. And now I'm back here, and I can turn on the NEMA. Well, and I've got NEMA. So that all looks good. That all looks good, so I can shut the NEMA off. I could turn this on. Is that going to hide my... Let me see if I can move. To what extent can I move that? Oh, okay, I can sort of move that. I want to look at the... Well, you can do all the things as before. You can click the GPS status and then see the... Oh, let's see. No? Oh, that's interesting. Okay, well, I did that on purpose to show you. Let me put it that way. Wait, that's... I didn't do that on purpose. I just don't know how to do it. Okay, so... Whoa, come on, man. Right there. Okay. So what happens is the iPhone, Apple does not transmit. It does not allow anybody, any app, to transmit the NEMA sentence that includes all the satellite information. Why? Nobody knows why that's true, but no iPhone app will ever transmit this two, I think it's GSA and GSV. Those are the two sentences you need to see the nice picture of the satellites. Okay, so what happened here? Oh, okay, let me start the NEMA and get that going just to illustrate this. Close. Okay, so now we have these things coming in. And let's see. Oh, okay. So you see here it's reading the data on the phone, and here it's reading over here. Now this is different by 1 millibar because inside of this qtVlm there is the option to set us an offset. So you can set. You can actually go in here and set an offset to the pressure. You could set that in here as well in the phone, but here you can set it. The other thing you can do is I press that and hold it, then you can actually show a graph. Now I think I don't think we have a control over that, but I think it's only submitting every 30 seconds the pressure. So right now what I'm going to do is I just turned on a plot of the pressure. I'm just going to lift the phone way up in the air, and that's going to make the pressure go down as I go up in the air, but it's only reading it every 30 seconds. So I'm going to have to talk about something else in the meantime while that pressure goes down. But anyway, you can see how you could plot a graph and have a barograph of your pressure. Your pressure that way. Now the heel angle's all over everywhere because I don't know what angle I'm holding it at up here in the sky. But let me bring it back down. The pressure works. We've tested this many times. It's just that it's only reading every 30 seconds. So let me just shut off that graph by a long press of this. Okay, now the heel is setting at 0 degrees. I'll just illustrate that. Now the phone is laying flat here on the table. So I'm going to just lift it up. That's about like 20 degrees. How good is my guess here? Okay, so that says it's 17 degrees that direction. Now, I don't know if it tells you plus or minus. No. Okay, that's another. You just have to keep in mind which side of the boat you're sitting on for now. And so that's leaned the other way. So that shows the heel angle, and that heel angle can go then into your wind calculations, so you get a more accurate true wind computation. Now let's see here. I'm going to now test one other thing. I'm going to rotate the phone to the right by 90 degrees, and you'll see that the heading has changed here. Now, I don't know exactly. I'd have to experiment with this a little bit more. But you see that you could actually rig this up to be a heading sensor for your vessel if you wanted to do that. Okay, so that's the demonstration. It's really, literally plug and play. It connects almost instantly. So having that app in your phone not only is a powerful navigation tool, but it's a backup set to your instruments. Needless to say, although we use this program in our course, we use the PC program in our course. This is and that's free. the PC and the Mac version is free. The full function that does all this magic in the App Store, in the apps, that's $30 purchase. But I just want to stress, that's a company in France. We have no financial interest to that whatsoever. We use it only because it is so such a powerful tool. Okay, so I'll end there.